So here's the start to my empirical analysis. So the first hypothesis I set out to test is that the diminishing returns to the 2010 HDI, or Human Development Index, with respect to energy and CO2 emissions, are independent of the normalization and or aggregation method employed. So the idea here is a lot of the thinking that I've applied comes down to that diminishing returns relationship between CO2 emissions and human development, that figure that I showed earlier. And so I need to make sure that that relationship is a robust relationship. So what I did was I did an HDI CO2 sensitivity analysis where I compared the way that the HDI is actually calculated to different normalization and aggregation methods. And then also I looked at individual country development pathways, the idea being that if this diminishing returns is a real relationship, we should see it not only in aggregate form, but also as individual countries increase its CO2 emissions and thus HDI. So I'll show the results of this investigation. So first, this figure explains how the HDI calculation is done graphically. So I've mentioned before that HDI has three indicators: health, measured by life expectancy at birth; the standard of living or income, measured by per capita gross national income; and education in terms of years of schooling. And so this is it's an average taken between the mean years of schooling that a person actually experiences in this dark blue diamonds, and then expected years of schooling. So when a child is born, how many years are they expected to spend in school? And so this data is then normalized on a 0 to 1 scale. So for example, to do this normalization for life expectancy, the goalposts that are used, the minimum is 20, and the observed maximum in Japan in 2011 is 83.2. So basically the values are plugged into this normalization equation. So the actual value of the country you're looking at goes here, and you subtract the minimum value, 20, and divide by the maximum value minus the minimum value. And so basically what this does is it rescales it on a 0 to 1 scale. So that's specifically how the health and education indicators are normalized. Now for income, there's sort of an additional step. So it uses this equation, but it basically takes the natural log of each component in this equation. And this is based on the idea that there is diminishing returns to income for a person's human well-being. So you can see already that there's some processes implicit in the HDI calculation that may be driving this diminishing returns that I'm basing a lot of my empirical observations from. And for that matter, you can also see that before you even do any normalization, there's diminishing returns to HDI, diminishing returns to life expectancy from CO2 emissions, and same thing here with education. So then the final step is, once you have all of these indices normalized, you then have to aggregate them together to one common value. And so this is done in the current version by taking a geometric mean. So you multiply the values in each indice, and then you raise it to the power of 1/3. So for my sensitivity analysis, basically I tested 4 different versions of the HDI. And the blue diamonds is the 2010 HDI version that I just went over. And then there's other 3 versions where I changed the process of normalization and aggregation. So the second version, which is shown in the black axis, which pretty close to the original control version of the HDI, employs the natural log in the equation to normalize income, but uses an arithmetic mean instead of a geometric mean. So it's a standard mean where you add the indices together and divide by 3. And then the next version in green triangles removes the natural log in normalizing the income dimension. So it just uses the standard dimension normalization process without the natural logs. And then employs a geometric mean. And then finally, in the version here in the red rectangles or squares, removes the natural log from the income normalization and then uses a arithmetic mean. And so you can see no matter which normalization and aggregation method that you use, you still see this diminishing returns relationship. But what it does change is sort of the rate of the diminishing returns, and also determines the values or the ranges of HDI attained. So basically what this says is that the HDI works pretty well as a comparative measure of HDI, but you don't want to take the value sort of for a single country and use it at face value by itself. So as a comparative measure, it's most useful. So now, when I look at the country development pathways, so I looked at 90 development pathways of different countries. So here we have the consumption-based emissions, as I talked about before. So emissions are allocated to the country that consumes those emissions. So it takes into account the net emission transfers. And then we have Human Development Index from the time period of 1990 to 2010, and I looked at this in 5-year intervals. And so here, I couldn't put all 90 pathways on the same graph. So what I did was I selected a diverse sample that shows countries at different development levels, and also shows sort of the different trajectories that I found. And I've color-coded these in a way that the green pathways indicate nations that support this diminishing returns hypothesis, or at least show, increases in emissions with increases in HDI. And then we have nations in red that show kind of like the opposite trajectory. So you see decreases in consumption-based emissions, yet you still see increases in Human Development Index. And then you have a lot of nations highlighted in yellow, and these are kind of what I call inconclusive nations, or nations that do like a lot of zigzagging all over the place, and you're not really sure what category they fit in. So most of the countries do fit, I think it's 56% of the nations I looked at fit in this inconclusive category. Although many of them are nations that have a Human Development Index above, say, 0.7. And so even though you're not seeing this diminishing returns in every individual nation, development pathway that I'm looking at, you do sort of see this pattern where you see more consistent trends among the least developed nations, and then sort of a decoupling type of relationship among the developed countries. So you see much more inconclusive and countries that display alternative trajectories in this developed nation space of the graph. And so in this category of inconclusive nations, I should mention these white arrows indicate time periods where HDI actually decreases over time. Everywhere else, HDI is increasing over the time period. And so this is South Africa, for example. So in this time period, South Africa had a section of its development pathway where it actually saw decreases in human development. So in this inconclusive category, I found a few patterns. And so these are mostly developed nations that show relatively consistent trends in that they are seeing increases in consumption-based CO2 emissions and increases in human development, at least for the majority of the pathway. But then in the last 5 years, you see a different trajectory where you see increases in human development but decreases in consumption-based CO2 emissions. And then also there's this group here where you see a similar phenomenon happening in the last 5 years, and you also see it happening in the early 1990s. And so basically this is economic recessions coming out through the data. So in the early 1990s, there was a recession associated with the Gulf War and spike in oil prices, and then we're more familiar with the most recent recession associated with the US housing bubble. And so this is really interesting because even though we're just looking sort of at a limited time frame, we do see examples where CO2 emissions are decreasing, but HDI is continuing to increase. And so this is kind of hopeful when you think about climate policy, and that maybe reducing CO2 emissions doesn't necessarily have to mean decreases in human development. And so finally, we zoom in on the least developed nations. And the least developed nations are defined here as nations that in 1990 had HDI levels below 0.5. And so, like I said, you see very consistent increasing trends as consumption-based emissions increase and human development increases. And these are particular 14 nations where this strong relationship exists. And so here are the key results for my first investigation. So neither the method of normalization or aggregation of HDI causes the diminishing returns, but it does influence the rate of return and the range of values attained. A general model of development for all nations is non-existent. And so you can see that represented in the diversity of trajectories that we saw. CO2 income reductions doesn't necessarily mean reductions in overall human development, and many of the low developed nations exhibit consistent and strong trends in HDI for small increases in CO2.